Timed one? Good job. Okay, here we go. One note. Okay, today's first lesson is on implicit differentiation. You use this a lot as the year goes along, so you really need to pay attention to this one. No, this isn't a formula, man. This is knowing how to do stuff.
Not a formula.
Yeah. Man, not ma'am. No, I actually said man, M-A-N. Just clean the wax out of your ears. Okay, implicit differentiation. Normally, in a normal equation, Ricky, you take a derivative of the x's, but hey, they stuck in a y. If we have a y and we're taking dy dx, we have to treat that special, okay? So, when you take a derivative of a y, you throw a dy dx behind it. So, finding the first derivative of this. What's the first derivative of x squared? 2x. And then you have to do the product rule for this. Okay? So it's plus x times the first derivative of y. Well, the first derivative of y with respect to x is dy dx. So when you take the first derivative with respect to x of y is dy dx. That's something to know. The first derivative, when you take a derivative of y with respect to x, it's dy dx. Okay. But we're doing the product rule for this middle one, right? So then it's x times the first derivative of y plus y times the first derivative of x. So it's plus y times the first derivative of x. Well, what's the first derivative of x? 1. Plus, okay, what's the first derivative of y cubed? 3y squared, but since it's with a y involved, you have to throw dy dx on the end of it. Equals 0, because the first derivative of 0 is 0. Now we got to simplify it. Okay, so it says find dy dx. We got to get dy dx alone on one side. So the two things with dy dx in it stay on the left-hand side. Everything else goes to the right-hand side. So x dy dx plus 3y squared dy dx equals negative y minus 2x, or negative 2x minus y, whatever we want to do. Okay? If we factor out a dy dx on the outside of the left-hand side, we get x plus 3y squared. That's supposed to be a parenthesis, but my computer doesn't work very good. I'm going to go negative 2x plus minus y over here, just because. Now, how do we get dy dx alone? Divide by x plus 3y squared. So dy dx equals negative 2x minus y over x plus 3y squared. That is implicit differentiation. And you'll say, we'll never have to use that. Well, yeah, it is helpful later on in calculus. Okay? All right. So now that we know how to do this, let's do this one really quick. Okay? What's the first step of this? Find the first derivative. What's the first derivative of 3x squared? 6x. And it's just 6x. There's no dy dx on it because there's no y's involved. Then you have to do the product rule for the next part. So it's negative x squared. What's first derivative of y? Dy dx. And then minus again, because if it was minus in front of it's plus for the product rule, but if there's a minus in front, both of them are minus. No, now it does. Because it's the first times the first derivative of that plus that times the first derivative of this. So it's minus y times the first derivative of x squared, which is 2x. There's no dy dx on that one because we're not taking the derivative of a y there. And so what's the derivative of y to the fourth? 4y cubed dy dx. What's the first derivative of 1? 0. So then you get dy dx alone on one side. So dy dx negative x squared plus 4y cubed. Everything else goes to the other side. Negative 6x plus 2xy. Because it's negative 2xy on the left side, so then it's plus 2xy on the other side. Divide. Okay? That's what dy dx equals. That's implicit differentiation. Yes. What equals 1?
The thing equals 1. The top thing. In the original thing, yeah.
The original equaled 1, but the first derivative of 1 is 0. We're taking the first derivative of both sides. Yeah. Take first derivative of both sides. So this is the slope of this. So if you had a point, if you were asked what's the slope at the point 2, 1 of this function, you could stick a 2 in there and a 1 in there and find the slope. Okay? But we're not doing that yet. Okay. Until down here. That's where we're finding the slope. Okay. So this one. So if we want to find the slope of this function, 2x minus 3x dy dx minus 3y. No, why is there dy dx?
It's just one. One for the y's. One for the x, I mean, right?
Plus equals 0.
So is it always going to equal 0? When it's just a number?
When it's just a number over there, but what if there's a 3x over there? Then b equals 3. It's you,
So when you put
yeah.
the dy dx, would you just put the first derivative?
Just wait till we take second derivatives with this stuff, and then we'll get to kind of what you're thinking of.
Is the reason you do the minus 3x dy dx minus 3y, is that all the product rule?
Yep, product rule. These
And
two
why
are
is
both
it-
product
so
rule.
why is it negative then?
Because product rule's adding, but we have a negative here.
Oh, okay.
So then they're both minus, or you could do addition with plus a negative, and it still end up minus. Okay, so dy dx on the left side, and then we go negative 3x plus 2y equals, and then the things without the dy dx move to the other side, negative 2x plus 3y. So if we divide, so if we stick the numbers in, it's negative 2 times 1 plus 3 times 0 over negative 3 times 1 plus 2 times 0. So it's negative 2 over negative 3, which is positive 2/3. That's the slope at the point 1, 0. Do we need to do this one, or I think you guys got it, right? Okay. Okay. Then the after lunch assignment, No, the after lunch assignment might be something else. This might be Wednesday now. Okay. So, figuring out what we have to do. Like the product rule and the product rule again, product rule and chain rule and the chain rule again. What do we do for something like this? Okay, so you have to look at this function and not cry. Okay. So we've got the product rule has to be done first because you have to take x squared times the first derivative of tangent of 2x to the fifth plus the tangent of 2x to the fifth times the first derivative of x squared. Okay? And then this thing, when you take the derivative of it, can you just take the derivative of it? No, you have to do the chain rule to it. So it's the product rule, then the chain rule. Now, for most of you, being seniors that want to get out of as much work as possible, you'll figure out that it's guess and check, but you'll use an educated guess to do it because you don't have to figure out the whole derivative stuff. Okay? So then you'll go, okay, let me look at this and then figure out the guess and check method. After getting a few wrong, you'll get a system down. I trust you guys. What? No. Well, there is. When you have two derivatives that are being added, then you add their derivatives. Okay. So this one, looking at this, what do you think first? The quotient rule, and then because it's squared, you have to apply the chain rule to that top part. So it's quotient rule, then the chain rule. No, I'm not going to. Okay, the next one. We're inside a square root. Okay? So what we've got going on is 3 cosine cubed of x to the 1/2 power. So when you take the derivative of it, you're going to go 1/2 times 3 cosine cubed of x to the negative 1/2 times the first derivative of the inside. Well, to take the first derivative of this, what would you have to do? The chain rule. So what did I do right here? Chain rule. So then it's the chain rule again. So do you have to find the whole derivative yet? No, you're just finding the process to get there. You don't have to find the whole derivative just yet. Yet. Okay, this one, I'm not in 100% agreement with the book or with Sal Khan, because this is the way I would do this. I would look at this and say, this is all one thing, because what's the square root of x? That's x to the, and x is x to the 1, so it would be 2x to the 3/2 times the sine of x. And then it would just be the product rule. No, it'd just be the product rule if it's written like this. And only the product rule. But because Sal wants us to do it in 3 separate things, it's a product rule and the product rule again when there's 3 separate things. Why is it the product rule again? Well, then you take 2x times the square root of x times the first derivative of the sine of x plus 2x times the sine of x times the first derivative of the square root of x plus the square root of x sine of x times the first derivative of 2x. That's another way of doing it. I just think, why not just rewrite it and do it? So much easier. So for this one, when there's three things, it's product rule again. I'll give that one to you because, again, I don't exactly answer. Okay, and then once you get done with that section, then we're actually going to figure them out. Okay? So what is this? Well, chain rule again, right? So this is 3 cosine cubed of x to the 1/2 power. So the first chain rule would be 1/2 times 3 cosine cubed of x to the negative 1/2 times the first derivative of the inside. Well, the inside is 3 times the cosine of x cubed. 3 times 3 is? 9 cosine of x squared times the first derivative of the inside of that, which is negative sine of x. So it's negative 9 cosine squared of x sine of x. That's what the first derivative of that inside part is. So in the end, we get, in the end, negative 9 cosine squared of x sine of x over 2 square root of 3 cosine cubed of x. And we can leave it like that. Yes, Trey.
How did you get that sine from the cosine?
Because we're doing the chain rule to this.
Yeah.
So the number comes out front, multiply, and then this stays the same to 1 less power, and then you have to take the first derivative of the inside. First derivative of cosine is negative sine.
I got you.
Okay. So, chain rule. Gets kind of complicated at times. Okay, let's look at this one. I'm going to rewrite this as the sine of 2x cubed plus 3x squared. Because that's really what it is. So what's the outer chain rule going to give you? 2 sine 2x cubed plus 3x to the first times the first derivative of the inside. So the sine of 2x cubed plus 3x, the first derivative of that is cosine of 2x cubed plus 3x times the first derivative of its inside, 6x plus 3. So you take all that times the cosine of 2x cubed plus 3x times 6x plus 3. So then what? 6x squared, yeah. Got it. Okay? So then, in the end, you'd write it as 12x squared plus 6, 2 times that, times the sine of 2x cubed plus 3x times the cosine of 2x cubed plus 3x. And this will be multiple choice. So you will be able to look at them and figure it out from there. Okay. And then this one. That's the product rule. Okay. This one, for me, simplify it first. This is 6x to the 3 plus 1/2 is 3.5 or 7/2 cosecant of x. So it's just a normal product rule. Okay? So it's 6x to the 7/2. What's the first derivative of cosecant of x? Note card.
One over sine squared.
No.
Negative
Cotangent.
cosecant.
No, negative cosecant.
Cotangent.
Oh, okay, I put them in the wrong order, but yeah. Right? And then plus cosecant of x times 42 halves, which is 21x to the 5 halves. Okay? Now, what are they going to do to you to like melt your mind a little bit? Well, on this one, they'll factor out a cosecant and they'll factor out whatever goes into here. So they'll factor out 3x to the 5 halves cosecant of x. They factor that out of each of these. Then what's left here is 2x cotangent of x, negative 2x cotangent of x, if you multiply what's left there. And then back here, what's left is 7. Just 7. Because we factored out
The 3 out of
3, and then the x to the 5 halves all came out, and the cosecant came out. And there it is. Trey.
How are you getting the 7 to the second? I know it has something to do with the square root, but I don't really get
Okay. This is 6, x to the third, x to the 1/2. So 3 plus 1/2 is 3.5. 2 times 3 is 6 plus 1 is 7. So 3.5 is the same as 7 halves.
So you add the exponents.
I got you. It's just whatever.
Yeah, change a mixed number to a improper fraction. Okay? Last one. I think this is the last one. Yeah, the last one. So this covers the whole week of what we're doing this week. Okay? How do we do this? Well, it's a product rule thing. Because we could do the product rule of these two, and then inside the product rule, do the product rule again. But when you have 3 things, it's just simpler to say, well, it's the first thing and the second thing times the first derivative of the third thing, plus the first thing and the third thing times the first derivative of the second thing, plus the second thing and the third thing times the first derivative of the first thing. So in the end, it's negative x to the 4 sine squared of x plus x to the 4th cosine squared of x plus 4x cubed sine x cosine x. Sal will re-explain all this. I gave you the quick and dirty version to figure out how to get it, but if you need to look at what Sal explains, you might actually have to plug in your headphones and listen to Sal a little bit for an explanation. All this is due next Monday, okay? But work on it as we go, and I'll answer what I can. But again, I'm going to be gone Wednesday and Friday. So, the more you get done, the sooner you get done, the better it is. So if you want me to push out those assignments, I need you to do something on Wednesday for the sub, because I don't know who it is. So I need you guys to be busy on Wednesday. So just do all of Wednesdays and Fridays on Wednesday. You should not have a problem with that. All right. So there you go.
It's set this up like a. How do we change it